12.4 is volume of prisms and cylinders. We are going to try to fly through this lesson, okay? Not because some of the things are not important, but mostly because we're running out of time. Okay? So we're going to fly through this. We're going to give you a good amount of work time so you can start on your chapter review after you finish your assignment, and then we'll do the same thing with 12.5 tomorrow. First of all, what is volume? What does that mean? But what is it? Yeah, it's how much goes inside, right? It's how much will fit inside. What is the label on something if you found volume? Yeah, units cubed. What you're trying to figure out is how many 1 by 1, that is not a very good cube, okay? How many 1 by 1 cubes, or 1 by 1 by 1 cubes fit inside of something? Okay, so that's why it's units cubed. Taking a look right away on page 743, we have 3 postulates. Again, we're going to fly through some of these things. I think you'll know most of these. Volume of a cube, you're going to be able to find that here in a little bit, so I'm not going to mess with that one. The volume congruence postulate states that if 2 polyhedra are congruent, then they have the same volume. What does it mean to be congruent? Austin? Exactly the same. So, if they're exactly the same, obviously they have the same volume, right? Okay, so that one should be fairly obvious to us. The volume addition postulate says the volume of a solid is the sum of the volumes of its its non-overlapping parts. What they're getting at there if you have a shape like this, how do you find the volume? Well, couldn't I cut it right here? And I could find the volume of this. And I could find the volume of this. And do what? Add them together. And then I'd have the volume of my whole shape, right? That's all they're getting at there with the volume addition postulate. I think most of you could have probably came up with that one on your own. So, questions on any of those 3? Like I said, we're going to try to breeze through this so you have as much time as possible. The next page we get to a theorem. We're not going to write this one down. It says if 2 solids have the same height and the same cross-sectional area at every level, then they have the same volume. So look below there. What they're getting at, everybody see the right prism below and the oblique prism? Everybody see those? They have the same volume. Not because they look the same, because they don't look the same, right? Okay? And if I were to take that oblique one and stand it up, it would actually be taller. Okay? But they have the same overall height as is, and they have the same cross-sectional shape, which is a square. Okay? So they actually end up having the same volume. Again, we could go in more into that if we were trying to really go through this lesson in detail. You're not going to necessarily have that on your test or quiz, or on your test or your assignment, I mean. Okay, but just be aware that 2 things don't have to look exactly the same to have the same volume. Okay, they could look differently and have the same volume as each other. Okay, the big thing is those next 2 theorems. We have the volume of a prism first. These are theorems. Now, the nice thing about this lesson is we've already done everything that we're going to need. We are just using a different formula. Okay? Can you find the area of an equilateral triangle? Yeah. Can you find the area of a right triangle? Can you find the area of a square? Rectangle? pentagon, hexagon, heptagon, octagon. You should be able to find the area of anything at this point, right? Pretty much. There's a couple things we haven't necessarily done area for. McKenna, you made a comment earlier. How do you find the volume of something? You guys have always been taught that the volume of something is length times width times height. That doesn't always work though. In a triangular prism, what's the length and what's the width? In an octagon, or an octagonal prism, or a hexagonal prism, what's the length and width? The height would be obvious, right? It'd be how tall it is. But can you find a length and a width of something that doesn't have a length or a width? No. So what I'm going to ask you to use as the volume is not length times width times height, even though that's what it says over there. Okay, we don't want to use that. We want to use volume equals the area of the base times the height. Isn't that the same thing for a rectangular prism? How would you find the area of the base over here? You'd take the length times the width, right? So is length times width times height wrong? Not for a rectangular prism. Okay, but for something like a triangular prism, it's just not going to work. Okay, so we're going to think of volume as the area of the base times the height. For volume of a cylinder, volume equals area of the base times the height. The only difference here is what? Yeah, the bases are circles, right? So if you wanted to, you could tell me that the volume equaled, how do you find the area of the base then? Pi r squared times h. Would those two things be exactly the same? Yeah, because the area of the base is a circle, or the base is a circle, so the area would be pi r squared. Questions before we do some example problems? Have we already found area of these bases? Yeah, so that's not new. Should you be able to find a height? Yeah, so that's not new either. Okay? So, just be aware that we've done all of it. We're just using a different equation now. Okay? So, looking on, we'll look at something that's like or similar to example 2. They give us this, and then they tell us this is 6 inches, 2.5 inches, and 3 inches. We have to find the volume. So we know volume's the area of the base times the height, right? You guys see why length and width wouldn't necessarily work here? Actually, here it seems that it would. But what shape is the base? And don't say square. Don't say rectangle. Why? There's 2 of them. Okay? At first glance, most of us want to say that this is the base. But how many is there? 1. So can that be the base? Not if it's a prism. Hey, what about this rectangle? No. Only one of those, right? That can't be a base. What about that rectangle? Only one of those. So it must be the triangles Because how many of those triangles are there? There's 2. With us, Travis? With us? So, when I find this, volume equals area of the base times the height, Vincent, how do I find the area of the base?
6 times 2.5
Good. 6 times 2.5 divided by 2. Careful, I thought you were going to bring that thing down. Okay. So 6 times 2.5 is, pardon? 15. And then divided by 2. So if you wanted to change it to a decimal, you could because it started with a decimal. Personally, I noticed that I got a whole number and then divided it by 2. I'm just going to leave it like that. Is that okay? Yeah, same thing, right? It's all the same. Mine's just in a fraction and yours is in a decimal. I need to multiply that times what? Not 6. Why 3, Travis? Right, we haven't used that yet. But if I were to take this prism, actually lay it over on its base so the triangle was down, 3 would end up being the height, right? Okay. So I have 3. So in a fraction, what do I get here? I get 45 halves. You guys probably got 22.5 if you did decimals, right? What would my label be? Inches cubed. Good. Be careful with that. We're transitioning from surface area to volume. We need to make sure we get the proper label. Travis? We already did. That's what we did right here. We took 6 times 2.5, which was 15, and then we divided it by 2. So that's how I got 15 over 2. Okay. Have to use what?
Do we have to use
The 3, yeah. Because that's your height. Yep, if you don't use that 3, then you're not finding the proper volume. Okay. Alright, I got 3 more examples for you. None are going to take super long. Most of this lessons, in most of these classes, only took us 20 minutes, so we'll breeze through these next few. Okay, I have a rectangular prism. Probably the worst one I've drawn all day. Okay, but what we're getting at here is that I have 11 centimeters by x centimeters by x centimeters. They tell us that the volume of this is 396 cubic centimeters. What do you suppose they're going to want us to find? The x's. They want us to find the x's. So we got to solve for x. Jacob, can you put that away, please? Okay. What am I going to have to use? What formula though? Volume, right? Okay. How do I know I'm going to have to use volume of a prism? Because it's a prism and they gave us the volume. So, I'm going to go ahead and set this up. I have 396 because I already know what V equals, right? Equals what, Carly? The area of the base is 11 times x, which is 11x. And then Ryan, the height is x. So do I have the area of the base times the height? Yeah. What is 11x times x, Jacob? It's 11x squared. Good. Okay, questions there? We good there? Now what, Jacob? Good. Divide by 11. 396 divided by 11 is 36 equals x squared. And then, well, but what did you do? square root it because it's already squared. You want those to cancel. So x equals 6. I did have the question in the first class, does that need to have a label? I mean, it's just x, right? So technically it doesn't. But I was telling them, it's probably a good habit just to do it all the time, isn't it? Okay? Because if you just do it all the time, are you ever going to miss it? No. If you put a label on x, I'm not going to count it wrong. But if you don't put a label on something that needs a label, then that's going to be wrong. Okay? Thanks, buddy. You okay? Okay. Okay, so go ahead and just label all the time. Save yourself the trouble of worrying whether you need to or not. Okay. I want to find x. Same kind of problem, right? Pretty similar. So I'm still going to have 100 equal to the area of my base times my height. But what's the area of my base now? X squared times my height, which is, so I actually have 100 equals x cubed. How do you undo cubing something? You guys may have never done this before, I'm not for sure. How do you undo squaring something? So how do you undo cubing something? Cube root. Okay? So, I need to take the cubed root of both sides, because those are going to cancel. So, one option for an answer, if you just wanted to leave it like this, that'd be okay. Okay? But I am going to show you how to put this into your calculator, because if it were a perfect cube, and it would come out as a whole number, I'm going to want that whole number. So, in your calculator, if you have your TIs, like what I have in the back, you're going to have to type your 3, and then you have this radical, which some of you accidentally use sometimes anyways, with the x on it, and then 100. What that's doing is it's taking this 3 and putting it on this radical. So this would be like the cube root of 100. You could do any radical with that. If you'd have had x to the 9th equals 100, you could put 9 x root 100 and you could find the 9th root. Does that make sense? So you can do any radical. Now, what do you get when you plug that in? 4.6. 4.6 basically. Okay. So, just be aware of that. Hey, this is possible to do. Okay. You are fine just leaving it like this, though, if you would like. Okay. Okay, ready for one last problem? Does everybody have that? Some people still writing. There's only a couple like that, but there might be one on your test. I'm not for sure. All right. The last one I want to do one with cylinders because we haven't done any of those yet. Actually, they tell me that the diameter is x, the height is 5 feet, and the volume, I believe, is 277. Yeah. Anybody see a catch here before we start this? What page? We don't know the radius. And the diameter has nothing to do with volume, right? So, how do I want to set this up? Do I want to use the diameter at all in my equation? No. I want to use what? Radius, because that's part of my equation. Once I know the radius, what can I do to my answer? Multiply it by 2 or double it, right? Okay. So, my volume, which is 277, this is just like the last few problems we've done. equals what, Jacob? You could. That's going to make it more challenging, though. I'm going to tell you just find the area of a circle, because that's what the base is, right? And we're trying to find the area of the base. So how do you do that? Don't even look at that variable. How do you find the area of a circle? That'd be the area of the base, right? Now, obviously, we don't know what r is, but if once I find it, I can use it and find the diameter. Times what? Times 5. Carson, what do you get here in terms of pi? Okay? Because it's all multiplication, so you can shift that around however you want. So now I have... Sorry? No, because these are not being added together. They're multiplied. If they're multiplied, you can rewrite it in any order. Now what? Divide by 5 pi. Now personally, I'm going to leave this as 277 over 5 pi. Because then I don't have to type anything in my calculator. I don't have to worry about decimals. I don't have to do any of that. Equals r squared. Now, square root. So r equals okay. Is that an acceptable answer? Yeah, that's fine. Now, is that what they wanted me to solve for, though? No, they wanted us to find the diameter, so I need to do what to that? So what's that going to look like? Yeah, it's just going to be 2 of those, right? Label would be feet. Bless you. Okay. So, would I count it wrong if you gave me the decimal? Not as long as it's the right decimal. Hey, I did have some people last class got the wrong answer. The correct answer for the problem that they were doing was like 218.63. They got 216.59. The reason is because when they were using their decimal, they rounded it to the nearest tenth and then kept using it. Hey, you remember back when I talked about if you round it too early, you get the wrong answer? They were more than 2 off. Okay, so it makes a huge difference once you're doing volume things. So be careful with that. Okay, there is a way to reduce this more. We'll worry about that next year in Algebra 2. I know that's a lot of stuff in a short amount of time, but really, we're not doing anything new than plugging things into a new equation. You already knew how to find the area of all the bases. Hey, you guys know what a height is. From there, we're just plugging it into a different formula. So you have 20 minutes to work on this assignment. Some of you will finish. A decent amount of people have finished this assignment.